Hey guys, it's Miss Landry, and today we're going to talk a little bit about energy of reactions. So, you guys know the four signs that a chemical reaction took place that I want you to know. They are color change, bubbles form, heat, like temperature change, and possible smell. It could also give off light. So, now we're going to look at how energy is transferred in a chemical reaction. So at the end of this video, you should be able to determine if a reaction is exothermic or endothermic. You should know the difference between reactants and products of a chemical reaction. You should be able to use a reaction coordinate diagram, not only to determine whether it's exothermic or endothermic, but also how much energy was transferred. And finally, you should be able to model energy transfers in a chemical reaction. So let's jump right in. First of all, you guys may not know this, but glass is actually a liquid. It just, when you think of flow or viscosity, it flows so slowly that we don't see it actually flowing. I thought that was kind of cool. I thought you guys would like that. So what is a chemical reaction? So there are some terms I'm going to want you guys to know. And let me get a different color because this background's a little funky. So whenever you have a chemical reaction, you're going to take two things, put them together, and get something totally new. So the things that you put together, we call those reactants. So I have reactant 1 and reactant 2. Sometimes you'll see it written as A plus B. So notice there's an arrow here, right? And a plus sign. So the plus indicates what I'm putting together. The arrow indicates that a chemical reaction has occurred. And when we say it as a reaction, we say it yields. So if you look down here, A plus B yields C. Okay, so here I have A plus B, and it's going to yield a product. So the product is always going to be to the right of the arrow, and the reactants are always going to be to the left of the arrow. So reactant equals product. And the reason we don't use equals, I mean, you can say equals, but in chemistry, we say the word yields because it makes that new chemical. All right, so now we have the terminology down, but I want to ask you a question. What do you think heat is? Like when you feel something hot or the sun is on you, like what is heat? In chemistry, it's actually, well, in the world, in the universe, it's actually energy. And I want you to picture making spaghetti, okay? So we take a pot of water and we put it on the stove and we turn on the stove. What I'm actually doing is adding heat, which is energy, to the water that's in that pot. And what happens is those molecules will start moving faster and faster and faster. And temperature is really just a measurement of that kinetic movement. So the faster those molecules move, the higher the temperature. It's kind of crazy to think about. When you think about different states of matter, so here I have solid, liquid, and gas, the particles move differently depending on what state they're in. So a solid, I know it doesn't seem like it, but the molecules in a solid still have some kinetic movement. So if you picture an ice cube, right, all of those water molecules are basically like in a lattice structure, like they make like cubes, not like an ice cube, but a cube shape. And where they are, they just like vibrate in that spot. Liquid, if you notice this picture, liquid, the molecules slide past each other. They're moving. They're definitely moving where they are. That's why you can pour it. And then gas is really different. Gas moves super fast. The molecules of gas, they have the most energy. And because they're moving so fast, they actually bounce off of each other and off of like the side of the container. That's what creates pressure on a container. So the more energy I have, the more heat, and therefore the more kinetic movement. So here's a little graph that kind of shows that. So as kinetic energy increases, temperature increases, and vice versa. As temperature increases, kinetic energy also increases. When you talk about energy, we use joules. It's pronounced joules, Joules, not Juul. But and then we because it's kind of a large number in chemistry, we tend to use kilojoules. The prefix kilo, or Kilo, stands for 1,000. So a kilojoule would be 1,000 joules. And then in chemistry, like around the world, we use Celsius. So no more Fahrenheit. We only use Celsius. Okay, so what is the energy of reactions? Like, how do we know that energy is being transferred in a chemical reaction? There's two types of reactions. So there's endothermic. Endothermic reactions tend to be less common, and they actually absorb heat from the surrounding environment. And that makes it actually feel cold. Now, I know if you've ever been injured, they take out like that instant cold pack, right? And they smash it and then they shake it and it gets cold. Well, what's happening is there's a chemical reaction occurring inside that pack that is taking in energy from the surrounding molecules. So the temperature around it is dropping because the kinetic motion is dropping. So that's what an endothermic reaction is. The best way to remember this is endothermic means it feels cold. Then there's exothermic, that's the other type. These are much more common. This is probably what you think of when you think of chemical reactions. These give off heat, they release heat, and it will feel warm or hot, kind of like our copper reaction. That was definitely an exothermic reaction. So you do need to know those two terms, exothermic and endothermic, and what they mean. Okay, now we're going to talk about something called a reaction coordinate diagram. This is the last thing that we need to know for the test, and this is pretty important, so I hope you guys pay attention to this. And there are steps for understanding this. So the first thing I want you to do is take a look at the axes. Let me get the pen. On the bottom, we have, it's basically time, right? So time or progress of reaction is going in that direction. Over here, I have energy, and again, this will probably be in kilojoules. So as this goes up, energy increases, okay? Now, notice that the reactants are right here. Reactants all start with a certain amount of energy. Everything has a certain amount of energy. So these are starting right here, okay? And then what will happen, hang on, is you have to add enough energy for the reaction to actually happen. I want you to think about riding a bike, right? Imagine you're riding a bike and you're at the bottom of a hill. In order to get going up that hill, which you can see right here, you have to add energy, and that's what's happening here. In this middle part here, it's in what we call a transition state, where the reactants are kind of really unstable and they're starting to switch and become a new chemical. So then we kind of drop down here, and here we have our product. And notice that in this case, the product has less energy, right? So we went from this amount of energy to this amount of energy. So I want you to think to yourself, what happened to the energy? Did I lose energy or did I gain energy? And you can do this with numbers. So like, let's just put some numbers on here. Let's say this is 500, right? 500 kilojoules. We know that down here is lower. So let's say this is 100 kilojoules. We've lost 400 kilojoules of energy. So therefore, it's releasing that energy, which makes this an exothermic reaction. So in an exothermic reaction, the reactants will always start higher than the products because it has to release that energy, okay? Let's go on. Now let's look at this one. So again, do all those steps, right? Here we have kilojoules, we have progress. I have my reactants over here, okay? Notice I still have that activation with the transitional state, and then I have my products here. So I want to ask you, which one has more energy, the reactants or the products in this sample? Reactants are here, products are here. So the products definitely have more energy by the end of this. So in order for the products, it's kind of hard to write, sorry guys. In order for the products to have more energy, did they have to gain energy or did they have to lose energy? And I would say in order to be higher than where you start, you have to gain energy. If it's gaining energy from around itself, it's gonna feel cold. Okay, so this would be endothermic. So in an endothermic reaction, the products will be higher on the kilojoule side than the reactants. Hope that makes sense. We'll try one more practice question, see how you do. So let's start with, is this exothermic or endothermic? And how can you tell? So take a second, pause the video if you want. Because the reactants start lower, right? And then I have products up a little higher, this is going to be endothermic. Because remember, I'm actually gaining energy in order for this reaction to occur. So that is endothermic. Now the question asks, here's a challenge question, how many kilojoules are gained or lost in this reaction? So you're gonna start here, here's my products, it's at about 300. My reactants are at 100. So I have gained 200 kilojoules of energy. That is what I'm taking from the surrounding environment. So that's how cold it's gonna feel. That is it for this video. I just have these little steps here to figure it out, but that's it for this video. Hope that helped, and make sure you have your notes for class, and I'll see you guys later. Thanks.